So this is about factoring with our difference or sum of cubes, and I'm actually going to change this one to a negative just to get some variety in here. But basically this follows a formula. As long as you know the formula, you can answer all of these. And the formula is always going to be when you have that's my cat. When you have a number cubed added to another number cubed, you can always figure out what it's going to be based on the formula like this. And it's very simple as long as you memorize the word soap. I know that's really random, but if you memorize the word soap, then you can easily figure out what the signs are going to be. So as we can see, we have a positive sign here, and so soap basically just means that, well, when you do this, your signs are going to be the same. So positive gave me positive right here. Opposite, they gave me a negative. And then the last one is always positive. AP, always positive. So we can see that our signs are going to be the same. And then, of course, the letters you have to go ahead and memorize. So we come up here to our first example, x cubed plus 64. And we just have to ask ourselves, well, what is the first thing multiplied by 3 times? And it's pretty obvious with a variable. It's just going to be x. But the next one is 64. Now, you can do upside down division, or you can actually just go into your calculator and do, okay, what is 2 times 2 times 2? That gives us 8. Okay, so we need to go higher. 3 times 3 times 3. That gives us 27. Okay, we need to go higher. 4 times 4 times 4. That gives us 64. So that is the number that we had to multiply by 3 times. And so now that we know what our A value is, this would be our A, and we know what our B value is, we can plug it into our formula down here. So I'm going to ignore the first part, and I'm just going to use the second part. That's going to be x plus 4. All right, then we go to the next parenthetical statement, which is x squared minus x times 4 plus 4 squared. And as we can see, there's some things that we can easily modify, like this x times 4. We can change that to make it look prettier. We make it 4x. And then the other thing we can do is we have 4 squared, which we can easily make as 16. So the next step after you plug it in is just to make it look pretty. This is going to give me x squared minus 4x plus 16. And this becomes my answer. So the next one is the same exact thing, but it's going to be slightly different in the fact that we might have some extra materials. For example, I can look at this and see that I need to take out my GCF. The GCF is always the first thing you need to look for. Is there a common factor we can take out? In this case, absolutely. We have t to the 4th power. So I'm going to take that out first. And then I'm going to look to see if I can take out any numbers. Well, the GCF between 16 and 250 is 2. So I know that I can divide everything by 2t to the 4th. So that's what I'm going to do. If I divide the first term by 2t to the 4th, that's going to give me 8t cubed. All right, carry down my minus sign. Do the same thing for 250. 250 divided by 2 is going to give me 125. And then if I take away t to the 4th, then that t to the 4th disappears. So I have completely factored out everything, or at least factored out the GCF. And now I need to apply my formula, which is down here. So this time it's a cubed minus b cubed equals a minus b, because it's got to be the same. That means the next part is a plus ab, because it's got to be the opposite. And then the last one is always just b squared. So I need to figure out what my a and b is. I need to look at the 8 this time. So in the previous example, it was just x. So I just had to worry about that. But now it's a number and a variable. And so because of that, I need to go to my calculator, figure out what that is. So I can try, 1 times 1 times 1 is just going to give me 1. So let's try 2. 2 times 2 times 2, that gives me 8. Perfect. So I know that this is actually a 2t to the 3rd power, because laws of exponents say that this would be 2 cubed, this would be t cubed, it would be 8t cubed. So this is exactly what I had. I just worked backwards. So I can erase all that. Now I do the same thing for the 125. 125, I'm going to try 5. 5 times 5 times 5. Yep, that was it. 5 cubed. So now that I have my A value and my B value, I'm going to plug it in. So the GCF is still there. It never disappears. It just sits in front until we are completely done. And again, I'm going to ignore this first piece, and I'm just going to plug into my parenthetical statements. So let's say 2t minus 5, and then it'll be, and I'm going to use parentheses this time, 2t squared plus 2t times 5 plus 5 squared. And I use parentheses this time just because this time I have a variable each time. I got that 2t. And so it's not as straightforward as like the x in our previous example. And so I just want to make sure I'm being extra careful when I do this. So now that I'm done with plugging it in, I have to make it look pretty. So it's going to say 2t to the 4th. That already looks pretty, so I don't need to do anything to that. Times 2t minus 5. All right, that one's done. Now I need to look at this piece. This piece, remember, you have to follow laws of exponents. Laws of exponents go to each term. And so really it's 2 squared, which is 4, and t squared, which is t squared. All right, now that I'm done with that, I can go to the next piece. 2 times 5 is 10t. And then finally, 5 squared is 25. And this is our completely factored difference of cubes.